So to say that you guys are lucky to be watching this tutorial is a massive understatement. The thing I'm about to show you in this video is so useful that I actually used it on a commercial that I was working on recently. Can't really talk about it because of NDA stuff, but I'm sure you can fill in the gaps. So in this tutorial, we are going to be making fully 100% procedural bubble streams that can go in any direction. You can control the bubble size, the flow, the rotation. The interesting thing about this though, why am I showing you this tutorial? Does it just like distribute on faces? No. The interesting thing about this tutorial is we're actually spawning in our own points. There is no distribution node that we're using. It is 100% raw math. So I need you guys to put on your thinking caps for this video. This one's harder than the usual one, but you are slated to learn more than a usual geometry nodes tutorial. So get ready. If I was you, I'd be getting your notebook and getting ready to start writing. Before we begin, make sure to take your elbow and just smash it on that subscribe button because you're not going to be wanting to miss more of these I feel like that sentence didn't come out right. Let's begin. So this is what we are making. So you can see pretty much as it was shown on render. We have these streams. You can use it for drink commercials. You can use it to do like power beams, like a Pokemon move, but it's all driven by this curve, right? If I was to do something like this, now it will follow the new arc of this curve. In fact, this is so procedural that instead of just using a group input, I can use any kind of curve at all. So here's a curve spiral, just attach it to the network. I mean, this spiral is probably pretty big, but you can see now it's flowing in a spiral. We can control the amount of the density, and ultimately you can see there's no point distribute node in here. In fact, we're doing some fancy vector rotate stuff. So I guess let's just get started. To begin, I'm going to get rid of everything, and this is all going to be driven by a curve. Again, why a curve? Because I want to define the path that stuff is flowing in. Easiest way to do that is to put down a curve that you can customize and then run geonodes through it, okay? For this curve, just make it a bit smoother before we begin, and then go to geonodes, make a geometry nodes group. So anything, any curve that we have here, it's being sent through this modifier. So order of operations. We're not going to be using a distribute points node. What do I mean by this? What we are not going to be doing, and this would be the easiest way out, and I'll explain the issue with it, is we're not going to be using a curve to mesh, where on the curve we take a circle. So you can see here I just turned it into a raw geometry, and you're like, okay, how do I get the bubbles to whatever? By distributing points on faces, right? This is how you get the bubbles. We're not doing this. Reason being, we need it to flow along the curve, and it's actually not very easy to do that when you have points distribute because we have no information about where it is along the curve and how to progress along the curve on each frame, right? It'd be easy if we had loops, but we don't have that. And this is going to cause a lot of popping because any change to this, I change the radius, I change the radius or whatever, it changes the amount of points, and if we have each one have its own scale, it's going to pop in and out. So we need a deterministic way of doing this. So we can't distribute points. How do I plan to do this? Here's how we're going to do it. Okay, this is one of the things I learned on this project. We are going to start off with a bunch of points. You can use a mesh line, a mesh circle, it doesn't matter. But I'm going to say 1,000 points. So I want you to imagine we have this line composed of 1,000 points going all the way up over here, okay? And what I want to do is I want to make a little rule that says for these 1,000 points, put them along the curve at different points. How are we going to do that? Well, for this mesh line, we're going to set position, right? So we're going to take each one. By the way, why am I whispering? It's 6 a.m. I'm in a hotel. There's people on this wall. and I'm about to do a 23-mile walk later, so I got to record this. Either way, we are setting position. So I'm taking these 1,000 points. I want to say for each of these points, put them somewhere. Where am I putting them? Well, we need to put them along the curve. So the trick is there's this sample curve node that was added kind of recently. What it does is it lets you take a curve, and it's going to sample it. It tells us information about its position, tangent, normal, for any point or any factor, any instruction we give it along the curve. What do I mean by this? So if I was to set this to factor, you can see that no matter what factor number I give this, anything between 0 and 1, it's going to output these three numbers. So how do I want to use this? And you'll see what this means in a second. If we use a random value and have it go between 0 and 1, in fact, what the factor is, it's a 0 to 1 slider. I connect this in here, and I take the position and connect it in here. You can see all of a sudden we get this chaos. What is this chaos? It's actually all the points being distributed along the curve. These edges, though, are what's composing the thing. So if I was to now do a instance on points, if you're not getting it, it's all about to make sense in a second. If I was to instance on points, so for each one of these modified points, I now put a sphere, and I make that sphere very tiny. You can now see our points are along the curve. So what happened here? We had this mesh line of 1,000 points that was just going up. I said put it along the curve. Set position where? On different points that we sampled along the curve for different factor numbers. So each one of these 1,000 things gets a number between 0 and 1. That's going to be a factor. And for that factor, it's going to say it's going to be 25% along the curve. Or for 1, it's going to be at this endpoint, 100%. So we're scattering it along the curve in this deterministic way. Why? Why is this better? This is better now because since this is now a factor input, which tells us how far along the curve we are, right? If I now do a math addition, what happens? It's going to slide along the curve. It's going to go from one endpoint to the other. It's a little hard to see right now. But you could see now we have a flow, right? We know how to progress along the curve because we're saying increase the factor and then distribute the points in that manner. Well, to see it more clearly, I don't want it to just be on the curve. I want it to kind of be in this cone or this cylinder around it, as we did with the distribute faces, even though we don't want that. So we somehow need to take these points and scatter them kind of outwards along the curve, but in a random direction, right? Almost like in this section right here, I want some points to kind of go out this way, some of them to go out this way, in 3 dimensions, some of them to go out vertical. We need to do that, right? And this is not easy to do mathematically. So here's the trick. Here's the trick. For the set position, we want to give a bit more of an instruction. So put it along the curve, but also kind of give it some girth, right? We're going to do that with vector math. So if I do an addition, I can now add an additional instruction. And what I want to do is I want to bring it out along the normal. So the curve has a normal going this way, and in this case it's going this way, changes, but it shows an outwards direction. So if I take the normal and connect it, and also add kind of a scale slider to say how strong this effect is, you can see now we're going outwards, right, in the way described. So again, this point right here will go in this direction, as you can see. Issue is all the points are going along the same normal. We need some randomizations, right? So I need some points to go out this way, some to go out this way. In other words, we need to take the normal vector and kind of rotate it about the axis of the curve, if you can imagine that, right? So we have a curve right here. I told you this tutorial would be tricky, but you're going to learn a lot. So the curve kind of goes along here in this section, and about this direction, I want to rotate this normal. So some goes this way, some goes this way, some goes this way, kind of like a free rotation. Well, to do that, we literally need to explicitly write out this rotation. So we're going to do vector rotate. So we're doing all of this from scratch, but it's going to give us so much control. We're going to rotate the normal vector about what's the center, or rather, where are we on the curve? Are we here? Are we here? Are we here? Where's the center? Well, that's exactly the position. And you're going to notice everything we need for this vector rotate is going to be right here. So we're rotating the normal from where it's starting, the position, and about what axis, right? What axis, which axis of rotation do we have? Well, it's the one that flows along the curve. And that is literally what tangent means, if you didn't know. So let me show you what this gives us. What this gives us is originally, if we do the scale, we get the same normal thing. But as we change the angle, you can see it's kind of going outwards in different directions. And the magic comes here. If we do a random value, I'm just going to change the seed to make sure we get more randomness. We do this. We increase it by, let's say, 360. So it's going to output an angle between 0 and 360 degrees. We increase this. Now you can see we're getting kind of the girth. Again, why? Because all the points right here, let's say, they're going outwards along a normal that's been rotated with this rule, which is going to give us pretty even scattering, right? If this was only 0 to 10 degrees, I guess this is in radians. But you could see we can kind of get only a half a curve, and you can kind of unfurl this. So you get a whole bunch of control, seriously. But either way, I'm going to scatter it by 20. And now you could really see the point I was trying to drive home. The key to this is, since this is all factor determined, now you can see we're flowing along the curve, right? And by the way, I should probably save it at this point. I'm going to call it Patreon Bubbles because I have a Patreon and you could download this as a blend file and you don't need to make it yourself. Link in the description. But it's all factor determined. That's the big fucking deal, okay? So you can see there's no popping in and out, nothing like that. The only weird thing is some of the points kind of collect on the endpoints, right? So they all collect right here, and then as we flow, they all kind of gather on the second endpoint. To kind of combat this and to kind of get more of a flow that goes on for longer, instead of 0 to 1, we can have it scatter between -1 and 1. What this means is we have a bit of leeway, right? It's kind of like the points keep on spawning until this addition goes beyond 1, in which case these factor numbers are all positive. And if you want it to go for very long, you make it like -5, and then you can just keep on adding, right? It will keep on flowing. But I'm going to go -1 to 1, and again, you can always increase the density. It's always going to follow these rules. Okay, so this is actually the core mechanic behind this. The rest of this is actually just making it look good, which might seem difficult, but it's actually pretty easy. We did the core logic in here. So how do we make it look good? Well, first of all, we want pinching. I want pinching on this endpoint and this endpoint, and I want this area to kind of be kind of rotund and very thick. Why is it not letting me erase? Let me erase. Nothing to erase. Whatever. Here, I'll give it something to erase. How do we do that? Well, I want to change the thickness of it. What is thickness in this rule set where we don't have curve to mesh? It's this scaling of the altered normal. So if I can put a gradient in here, then we're fucking, you know? And I want to be fucking. So let's take an RGB curves. Let's take again, the factor tells us exactly where we are along the curve. This addition tells us where we are with this animation, right? So I'm going to take the animated factor. Again, that tells us where we are on the curve. I'm going to connect it to an RGB curves, connect that to scale. And it's going to look a bit weird to begin with, but what this is going to let us do, so right now I've set scale to 0 everywhere. It's flatlined. What this is going to let us do is kind of shape this at different points. As you can see, I'm kind of shaping it towards the end. You have this kind of shape that we're generating. And I want you to ignore these endpoints that are doing weird things for now. We'll fix that, but it's letting us shape it, if you can see. So here's that versus that. And the shape I want is one where this is centered at 0.5, so we kind of have this hill, and I don't want it to be that thick. So something like this. So it starts off pinched at 0, and then it gets thicker, thicker, thicker relative to this curve. And you could also make that linear if you wanted to. Or you could do whatever you want with it, and then it gets thinner, thinner, thinner. And again, you can control where that tapering happens and everything. And now we have this thing, which again is totally arbitrary. It works with any curve. But the cool thing about this is now when we add, it follows that thickness rule as it flows, right? If instead we did this just for the factor before we did the addition, think about what the issue would be. The issue would be that the flow does this because it doesn't know where it is with the updates, right? So this is the key insight. Let's get rid of these points. So how would I get rid of all this extra junk? Because again, we have all these points kind of accumulated, getting ready to go along the curve, and then they spawn in, and then they kind of gather over here. How do we get rid of them? Well, what I want to say is for anything with the factor very close to 0 or very close to 1, again, that's how we're describing endpoints. Everything we're doing is factor determined, right? I want you to tattoo that onto your forehead so that when you go to prison, you're like, oh, you saw the tutorial as well, and you guys could not get beat up there, you know? Everything's factor determined. If I can isolate factors equal to 0 and 1 or very close to it, and say for those, kind of either delete them or move them off to the side, we're doing good. In fact, you don't want to delete them, otherwise we get the popping because the indexing will always change. We want to take the same number of points. They never change. I don't want to get rid of any of them. The ones that we don't like, I'm just going to move them somewhere else, right? So how do I do that? Well, to move them, we're going to, again, exploit the set position, or, maybe to keep it cleaner, we could add another one, but there's no reason you can't. For this set position, I want to isolate. I want to make a selection for factor 0 and 1, and then move them. How do I do that? Well, again, we take our factor, not just the random value factor, but the animated one, again, the updated one. You take it, And I want to say, where is this greater than like 0.99? I don't want to explicitly say 1 because then it might be a bit glitchy. I want to make sure it's really capturing it. So anything bigger than 0.99 and anything less than 0.01. So again, I'm basically saying 0 and 1. I'm isolating those. Combine those. So I'm saying for addition, anything that's either this or that. Use this as a selection. So again, we're setting position and I'm isolating this. Offset it. So you can see we've kind of taken those chunks and now we can control them. And I'm just going to bring them up on the y-axis by 100. So they're going to be way off over here. Again, the reason I'm doing this with set position and not with delete geometry is I want to make sure there's always the same number of points. Otherwise, we're going to get flickering. That's very important. So now what we can do is this actually is kind of, it's not the finished effect, but this is the finished tapering. If I now take a scene time node and just put it in here, so I don't need a keyframe, you can see it does it itself. Beautiful, right? In fact, we could add a multiplication or a division, probably a division, to control the speed. So if I divide by 5, this is now going to flow 5 times slower, and you can see it's all very predictable. In fact, we could add a second kind of movement, so it's moving along the factor, but we've also made a function for our rotation. With this vector rotate, we could have it kind of tilt. We can generate a curve tilt the same way we generated a curve radius almost. What do I mean? Well, we can take this random thing, again, this is saying kind of the orbit, as you can see, and we can add, right? If we add, you can see it's rotating in a very deterministic way about its tangent, about its position, right? And I can do the same thing. I take this, make a new time function, we'll start divided by 1 and add it here. And now you can see we have some twisting. If you divide, maybe multiply. If you multiply by 2, it's going to be twisting twice as fast. 5, it's going to be twisting a lot. And there's reasons that you'd want either of these. Okay? Maybe one more thing before I start scaling them and maybe giving them material is I want an animation in because it kind of just exists, right? And it works, right? I can extrude and it's going to follow the rule set. But I want it to not just kind of always exist. I want it to appear. Easy way I found to do this for the project I was working on is a trim curve. So again, this group input geometry is the Bezier curve that we're starting with, right? This is the input, right? So if I trim curve, this is going to say kind of slice it. So we can slice it this way. And you can see that no matter what we do, you can see it almost has this nice animation where it kind of gathers and conserves its volume because everything afterwards is determined by this. So the radius and all that, it kind of stretches with it because again, it's factor determined. What do I mean? I mean, if I now, so I want it to start at 0 and kind of pop in, go from 0 to 1. If I take my seconds animation, again, driving, or my seconds input, driving all of this, you could see as the seconds go from 0 to 1, it kind of spawns in. It does this nice thing. In fact, if you want a bit more control, interesting thing is if you set this to power, so power 1 means don't change anything, but as you increase this exponent, you could see we're kind of getting a smoother animation, right? If I was to set this to 4, it'd kind of be whoop. Kind of gathering momentum. So I'm going to set this to 2.5. And another thing we can control is how fast this is happening. So if I multiply this by 2, you can see it's happening very quickly. If I multiply it by 1, it takes its time. If I multiply it by 0.4, it's going to be a slow thing, right? So we can kind of control all of this. So here's some settings I happen to like. So we have this draw in. Again, anything we do, I'm going to extrude, I'm going to rotate. Let's see what that looks like. It's going to draw in perfectly, always. And if it's looking pretty thin in some sections, that's just because of the how sharply the tangent, the concavity, how sharply the tangent changes. But it works with any curve. Again, you could even use I wonder if you could use I haven't tried a closed form. Let's try one. This might work and it might not. So what I mean by this is a cyclic curve. It doesn't have endpoints. It does not work. But if I take the set cyclic node, I bet it will. Set spline cyclic disable. It does not seem it does not seem to like this closed form one. Which is, arguably understandable. But you take a normal curve that actually has endpoints and it should work. Let's see, curve spiral. There we go. And I'm sure you could get the circle to work. You just gotta kind of make it from scratch using an arc or whatever. Okay, let's go back to the group input and let's finish off this project. So we now have this rule set where this thing spawns in on an arbitrary curve, it twists, it animates, and eventually it's going to run out, which is kind of cool because it will just kind of disappear. But we need to make it look more dynamic. Great way to do that is all the circles are the same size. Again, these are the points that we're spawning in and then using math to say where they are, right? So you can change the number of those. These are the points I want to scale. So again, remember at the very end, we're instancing on points. Everything before this is just this mess that we've created, you know? And it's going all the way up because we move those endpoints to y100 if you remember. But this is almost like a cool render that you could make. But we instanced it, so we have a bunch of spheres. If we now use a random value, and this is actually going to bring up a point that took me a while to understand. If you take it and put it on scale, you can see it's doing this weird thing where the first spheres are pretty big, and then they get smaller and smaller and smaller, which is not how you'd expect randomized to work. I mean, it's cool, but not how you'd expect it to work. This is because the reason it's doing this is the seed is set to a 0, which is something that's been used before. So it's not actually random. You got to make sure this is a different number. I fiddled around with it for so long. And you can see you just change the number, now it's actually randomized, right? And we can actually make a little function for this, where instead of everything going from 0 to 1, I want to have a bit more control. What I want to say is I want to say for all of this, go from 0 to 1, but also leave a tiny bit of area over here. And I'm going to put a handle over here. Add a tiny bit of area over here, where if anything happens to be the last 5%, right, anything from 0.95 to 1, make the value like 3 or something. So you can see very few of these are actually big bubbles. In fact, 3 is too big, I'll make it 2. And you can kind of change the probability of that happening. So again, most of them are going from 0 to 1, but you have some bubbles that happen to be 2. And by the way, you can always change the seed and get a different distribution if they look not random enough. So I think that looks pretty good, honestly. Maybe one more thing. I don't think I added this in my original, but one more thing you could do is you could have the scale kind of go down at the taper points, and this would be super easy. Why? Say it with me. You have it tattooed on your head. You're in jail, remember? Factor determined. It's factor determined. So what do I mean by this? And I think I did this for my original NDA one, but I didn't do it for the demo. What I could do is I can multiply this by some factor, right? And that factor is going to be a color ramp that I'm going to make. So I'm going to reset. Again, if I want this to be factor determined, we don't use the random value from here. We use the added version. That's going to get sampled, right? Take it, connect it. And if I do it like this without changing the color ramp, what's going to happen? It's going to start off small and go big. But it kind of, how do I say this? It always does it relative to the factor, so it looks like correct. It's a little hard to explain. But what I want to do is I want to taper them on the edges. So for the 2 corners, make them black. And then in the middle, make it full scale white. So you can see in the middle, it has full radius, and then it kind of shrinks. In fact, probably what we want to do here is have one of these close to one endpoint at 0.1 and the other one at 0.9. So you can see now we have this nice scaling. So here is before and after. Okay. I think final thing, and you know, to make this look good, it's really just a matter, I think it already looks good, but to make it look the way you want is just a matter of fiddling with the numbers. You have all the controls. Now let's just make it look like bubbles. So let's do that simply. I'm going to use Cycles Render Engine. You can see we've basically rendered a bunch of spheres with no lighting or anything. I'm going to use an HDRI. This part I'm just going to basically skip over because I don't think it's that important. I'm just going to use an HDRI, get rid of it in my viewport. So now you could see we have this, you can't see, but we have an HDRI photosphere lighting this. And I just want to give it a material. So we could do it right here because the sphere is what's getting instanced. So apply a material. And then for the material, you want to give it a watery, bubbly, refractive-y material. And a simple way to do that is you go into your material, you make it transmissive, in other words, see-through. And by the way, we should probably make that sphere smooth, set shade smooth. Transmissive, low roughness, This is what's going to make it like super reflective, and transparent glass is going to let us see through it. So now you can see these all kind of look like bubbles. And you could try to do some weird stuff here where you isolate the boundaries, like with this Fresnel right here. And you could do a tiny bit of an emissive. Let's see what that looks like. Just so they're outlined a bit more. And you can control kind of the strength of that. I think that actually looks pretty good. I think it wouldn't look complete without that. So here's without, here's with. And that's kind of the deal, right? So let's mess around with some numbers. I'm going to make it 2.5 times denser. So it looks much fuller. And yeah, that looks nice. And by the way, you can also randomize this, like how high it goes, so that it's not just kind of like this hollow. Right now you can see it's this hollow thing, but you can actually have it occupy volume if you wanted it to. That's just another math function. I'm not doing that in this tutorial. Let me know if you care. I'll do it in the part 2. But you can see that that's your bubble beam, right? And it's fully procedural. I think I've driven the point home. Okay, 26 minutes. Whew. Okay, so there you go. The camera was on my forehead the whole time. That's okay. Hopefully you learned, I know you learned something. I learned a lot while making this project, so I wanted to share it. Hopefully you gained some insights that you can take with you from this tutorial. And as always, at the end of these tuts, I always mention Patreon. And don't click away. I'm not allowing you. There's reasons to join Patreon. So link in the description. 3 main reasons to join Patreon. Well, 4. First reason is it's the best way to support this channel and CG Matter. It's not the only reason, but it's pretty much the only reason that I can keep both these channels going while doing my shenanigans. So I really appreciate all 750, 60 some patrons that are actively funding this channel right now, and you could be part of them. But there's 3 reasons you should join. First one, early access to tutorials. You could have seen this tutorial early. I uploaded it before, day before you saw this. So other people saw it before you. Second of all, blend file. Huge for this one. You could just download the blend file here, and you don't need to make it yourself. And I've made hundreds of blend files at this point since I've been doing it for 3 years some. So there's a lot of blends you can download all at once. Third, exclusive tutorials that I upload every once in a while. I've been pretty inconsistent, but you get access to all the ones I've already made, which is quite a few at this point. Some of them are tutorial series. I got to get on this month's one. I gotta make one soon. This one was actually supposed to be an exclusive, but I'm like, nah, it's too good. I gotta share it with everybody. But I gotta do one soon. Either way, Patreon, it exists. Link in the description. Best way to fund this channel and the CG Matter channel, and you get stuff in return that I think is actually worth it. Like I do. This blend file is definitely worth something at minimum, and there's hundreds of blend files. So, thank you for watching, and yeah.